Hey everyone, my name is Krishan. I am a developer advocate here at Airbyte. And in this edition of our Airbyte Community Call, I am happy to introduce to y'all Ziku, who is the head of solution architecture at Fauna. Seriously, I want to thank you so much for joining us on our community call today. Really, I've been looking forward to this.
Thanks, Chris. Fortunately, it's a really appropriate time for me. It's noon. Um, but for you, yeah, I think you're in a part of the world where it's really early.
Yeah,
But
it's only 4 in the morning, but that's totally fine. I've adjusted my schedule. I've been working from 1 a.m. to like 10 a.m. the last 3 weeks or 4 weeks I've been here in the Philippines. So totally fine. But I think what's more challenging is the fact that you chose to do this at 12 p.m. lunchtime. I think that alone is impressive on your end.
I mean, in normal times of the year, this is probably the only time where I can do extra things.
Mm.
But it's end of the year now, so it's pretty chill. So
Definitely, definitely. And before we get into the demo, I just want to let everyone know if you do have a question, please go ahead and don't hesitate to ask. So I can see that we can see the questions are on our end and make sure that Z can ask any questions you have. If not, I have a ton of questions on my end that I want to ask as well. So again, Z, I want to thank you so much for joining us. And if you want, you can go ahead and start sharing your screen and go into the demo.
let's see. In the time that we have, it's gonna be a bit half. I wanna always start with a little bit of slide, give you some visual. A lot of people haven't heard of Fauna. Like what is this? What does it have to do
Mhm.
with Airbyte? So it's good to introduce what it is. We are a database. As you know, Airbyte folks all use Airbyte. We all work with databases. There's actually two types, right? You've got your operational slash transactional database, and then you got your OLAPs, your analytical database. We're on the transactional side. This is the database that you put behind your application and powers your application. So we're that type of database. We are actually very new, a type of new architecture, not based on anything that's legacy, classic, with an API delivery model. So think of us as the Stripe for databases, Twilio for databases.
Nice, nice example.
A big cliche, right? Three takeaways, three main things to note to grok about Fauna. The data model is what we call document relational. So it's a document database, kind of like MongoDB, kind of like Cassandra, but it actually supports joins relations. That's first class citizens. Like I said before, delivered as an API. There's really nothing to manage. We make a big deal out of that. And then distributed by default. If you're an operator or a database, you probably know about this word, distribution, right? So data in your database, or maybe your database nodes or your database itself, what you usually want to do when it's live and at scale is you want to have replicas, basically copy of that data for durability, right? So if you lose one, you can always recover it. And then because they're actually replicas, you start to basically place those replicas where you need it, i.e. closer to your users, right? That's basically the problem of distribution. And we actually abstract that away from you as the operator. So it's actually a really big deal that we make also. Now, I want to give you a history lesson. So Chris, you're going, well, we've done all this before. Why do we need a database? Press
There's so
why.
many databases out there right now. Yeah, that's a good question to
There's
ask yourself.
so I think well, you answered it. Why there's so many databases? I think it's good to look at the slide here. I'll build it out. We've been doing this for 5 decades. Look at that, man. 1970. 5 decades worth of databases. Why do we have so many databases? Well, because your needs are going to change over time. So let me illustrate. Well, of course, this is what we start with. I don't want to go further than this, but Oracle, Microsoft SQL Server. I actually used all these databases before. IBM, even IBM DB2. I used all three of these before. That's really when you have those client server apps, much older than I seem actually. But then maybe some of you guys, like are more familiar with these ones. So the first web apps that came out closer to what 2000s, right, based on the open source MySQL, the Postgres, right, which are really based on all these granddaddies, the Oracle database. They give you the scale, and of course that price performance goes away. Like you don't want to pay the tons and tons of money to Oracle to run something at scale when you're Yahoo. Well, these guys really took off your first gen web apps around this time because web apps, other types of databases, data stores also showed up, right, to make web apps possible, just informational. And then when you get to the 2000s, web really just started scaling globally. These companies, right, the Googles, the Yahoos, the Amazons, They had to scale the engineering muscle, and internally they created their own database technology. They R&D'd all this stuff. So there's Hadoop BigQuery Spanner from Google, Amazon Dynamo. We can talk a lot about Dynamo. Dynamo powers Amazon.com, the e-commerce site. For those of you, right, who actually don't know this. And then when AWS came out, they took that same technology and they commercialized it, right? So you can use DynamoDB out of AWS, but it's that same technology, that huge scale that it provides you. We got even bigger. Facebook, Twitter, right? These companies showed up. Twitter in the billions. We're looking at throughputs in the billions when it's Twitter and Facebook here. And then the science kept evolving to meet those needs. So Cassandra actually came from the guy who wrote Dynamo at Amazon. So he went to Facebook and then he created Cassandra. It's a document database. And the key attribute about document databases is they horizontally scale. You add more nodes, you get more scale, horizontal. That's different from MySQL, Postgres. It's different from all these RDBMS. You have to vertically scale these things. You have to wait for the hardware to be available. I mean, computing, right, follows that Moore's law. It just gets more powerful. Storage gets cheaper. So it does work. But Cassandra is based on horizontal scaling. MongoDB, very, very famous database, doing really well right now. Same thing. Document database, horizontally scales, no schemas, very flexible. Right, dealing with schemas are painful. And again, we go into the cloud era, the container era. AWS shows up. This is a big shift here. Some big earthquake happened, a big shift here, people moving to the cloud. And then AWS itself being able to offer you RDS, manage your relational databases for you. AWS making Dynamo available as a service. Big shift here in the database world. And then you move forward, another shift happening, SaaS. So, right, prove the business model. The cockroaches, which is ProtoDB, is based on Postgres. Yugabyte is based on Cassandra. PlanScale is based on MySQL. Again, all use the existing science that were invented before, but added like a SaaS model on top of it, right? So these folks are going to manage all this for you, so you don't have to manage it. Well, maybe you're right, Greg. Maybe I need to do a bit more research. I sort of think that the granddaddy of all these distributed NoSQL databases come from. Oh, okay, Greg.
We have some very knowledgeable, people in our community.
There we go. Anyways, I will correct my slide for next time.
And just for those who are watching on YouTube, Greg asked, "Isn't Yugabyte a fork of early Apache Kudu?"
Yep.
And Greg ended up being someone who worked there, so that was perfect.
Yeah. Thanks for that. I will do my research on this. I'm no expert, right? I even borrowed this slide and clean it up. So, okay, so we got all this. Another big shift in architecture is what we think is coming, and that's serverless. I guess if you're thinking in context of building web apps, serverless here means things like serverless compute environments, Cloudflare workers, fastly compute at edge, things like that. So we built our database to be able to meet the architecture that we think is going to come when folks become more and more serverless, right? So we go from cloud containers to serverless. And then we took also all the reasons why folks liked or we invented document databases that scale horizontally. We had to take that. So Fauna is based on it is a document database. It'll scale horizontally. That's really what it is. Our storage engine is based on one of these. But then we also took what we think were really important in the DevX to be able to iterate on your model as you go, to be able to express joins and relations. That's really important. So we also took that. And then what is Cockroach and PlanetScale really promising here is managed distribution of your database. So we also took that because that's a need, which also aligns with what serverless is offering, basically distribution of your compute for your server load is basically distributed. So do we need new databases? Obviously, history proved that we do need it, because I think the simple argument is the needs are going to change, the architecture is going to change, right? And the world's shrinking.
And just to add, like, Fauna is more of a hybrid database, right?
You
some
can
people
take
ask some questions about that. Like, Fauna is more a hybrid database. They feel paranoid about using Fauna because of that.
I think when you come in, your mental model is it is a document database, but it supports that joins and relations as first-class citizens, right? If you're used to using document databases, you'll find that you force down some compromises, denormalize your data, do a lot of duplication. Because that they could not support the joins. I think instinctively what you wanted to do is express those relations. So essentially, that's what we just give to you. It's kind of like, hey, it's the document database, but we just put something that was missing before. That's what we really believe, the ability to have those, right? So it really has that iterable relational data modeling that you actually want and enjoy as a developer. But underlying that, it offers the scaling promises of NoSQL database. No schema as well, so it's really very flexible. So at a glance, that we talk about that, Dillard as truly as an API. The closest comparison here, DynamoDB, is truly right. You just use it. You don't hit any limits. It just use it as much as you want. Actually, model is consumption based. Closest here is Dynamo. The other types of operationless offerings from the other guys are really not truly serverless. They're not, because you always pick some sort of size. You pick a size. Right? It's like, I want the small box, the medium box, the large box, the double XL, the triple XL. You pick the size. So you get all that capacity even though you're not using it. And then when you hit the capacity, you kind of pause for a while, get throttled. I have to upgrade to a bigger size. That's what all the others do. Okay? Because underlying it, it's the same old technology. It's Postgres. So they have to work this way, vertically scaling. This is what our secret sauce is. This one, ACID by default, and it's serializable globally. So this is a distributed database that is ACID compliant, right? We're not basing it off an old technology. There's a transaction protocol called Calvin that makes this happen. We're not the only ones to do it, by the way. There are others that actually use a similar strategy to achieve this. It's important to note that, yes, you can have your ACID compliance on a distributed database and sacrifice very little in latency. You might see some of this when I show you a demo.
So you're distributed and ACID compliant?
Yep.
How do you do that?
I mean, the Kelvin protocol at the high level, it's sort of like this. You have your replicas basically watch a log. So when you send a query to the database to where an API, you send it to the API and the router layer. It first goes to the log, and the log itself is distributed and global. So it goes to the log and becomes durable in the log. That's really the only latency that we have to pay for. It goes to the log makes it durable and basically make copies of it. And then there's some algorithm that determines the order of all the transactions that go in. It has to order it, right? That's where the serializable global serialization goes. There's one log, it orders it. Now, all the replicas, there could be many, many replicas. I'm going to tell you there's 3 replicas. We put them far apart, okay? So if you, in the US, it's like US West, one in Ohio, and then one in Virginia. So what the replicas are doing is just watching the logs, literally streaming, and then these replicas can apply the transaction logs all independently. That's the gist of it. So that's how the strategy works.
Wow, okay.
You'll see in the demo how fast, like, I'm not making this claim, right? I'm try it yourself. Pretty good. The type of the commits you do, so reading your own writes, I write something and immediately read it back. That's internally about 50 milliseconds-ish. That's on average of all the transactions we're seeing from across all our users. That's for our US region group, so the US footprint. So it's 50 internally, right? You have to account for, of course, that network internet latency, which again, it will happen. The latency will be from you to the replica. So there's one in California, one in Ohio, and one in Virginia, if you're looking at the US footprint. And you know, I think I talked about this already, replication model. This slide is the last thing I really want to talk about Fauna. Everything so far I talked about architecture, what differentiates. The other thing is basically comes with features. I'll call out the main one. So you basically can integrate it with an identity provider. So you can plug one of these in with something like a total of 3 mouse clicks on both ends. You would basically set up an integration to auth the database, right? You think of it as an API platform that is HTTP, you access it, right? You need some sort of auth, basically bear token. That can be done with any one of these JWT-based identity providers. Even if you don't use it, we have auth built in to the database itself. We use, which is very similar to something that Firestore does. If some of you guys use Firestore, it has that auth built into it. So you do a login, we basically store hash passwords inside database itself. You log in, provide password, you get an access token, you use that, which means you can do things really cool like build a mobile app and not have a server at all, right? Have a mobile app login, it's like this interacting with Fauna directly, auth built in, and authorization. There's a very robust authorization engine going on in there. And can write rules basically that basically say, hey, if I'm user blah 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 blah, and I have a role, I have something, some attribute about my JWT token, I can basically use that to power some logic that says return this row, don't return that row, return this column. It goes pretty granular. You have to write it out, of course, but it is possible. We have integration. These are partners, not Notify or Sell. You go in these systems, they can pick a data source on us in one of these. These are all your infrastructureless platforms. This is where, again, we think the world's going to go to. It's a matter of when. And then I'll skip over this. Native GraphQL. We wrote our own GraphQL server. Basically, it's bilingual. So you either learn our query language called FQL, right? Which I recommend everyone does. Or you skip it. You just use GraphQL. GraphQL basically,
Nice.
right, it has an auto resolver. So it resolves GraphQL into FQL.
Mm,
Yeah, so it's kind of bilingual that way. Really good.
nice.
Get started. Just want to just do like a shortcut.
That's helpful with GraphQL being as popular as well. So we appreciate that.
Yep. And then right, so this is a good segue. This is about like the maybe ecosystem or tooling, or hey, it's actually a database plus, right? So yeah, we have tools. It's where Airbyte comes in. We built it because our customers asked us to. Right, so customers at this end of the enterprise, the Jamstacky guys, maybe no need for it, but if you're building SaaS apps, enterprise apps, if you're actually running analytics, it's not the best place. Like I mentioned before, it's not OLAP database. SQL is the king here. So they're doing things in Snowflake, essentially. They're doing things in Redshift.
Yep.
Oh, we just want a way to get that data over there. Prior to writing this integration, they have to do it themselves. But that's why we built this thing. And then the plus here is that folks now say, when they come early, and say, hey, what's the exit plan? Well, use Airbyte, is right, transform it
Yes.
into your database. Let's probably save you time. So I like to use that when talk to them. But yeah, let's show you a quick demo. Create a database. I'm not waiting, so you can pick one of these. Okay, I'm gonna pick US. What are these you're talking about? So US is like this. EU is like that. Tree replicas. Classic is like this. That's what we're talking about. And then in the future, we're going to plan on putting the same thing all over the place. I'm going to do US, and then I'm going to pick use demo data. That's just an option getting started. See, we populated it with collections, put data in it, indexes and stuff. So I'm going to show you real quick what we mean by document database that can do joins. So here we have orders. This is like a e-commerce sort of schema you're looking at. I got customers, I got products, I got orders. These are my products: Hubs, Piñata, Pizza, blah, blah, blah. These are the primary keys: 201, 202, 3, 4. If you look at an order, right, it's got a shopping cart, and I'm only referencing the product. So normally in a document database, you denormalize. You actually stuff the thing in there, and you have to do a lot of duplication. This is relational database. If you're joining it, I'm going to write a query for you where we actually bring it back together. Status processing. Okay, I'm going to write a query. Give me all the orders and the processing status. Show me the order status and then the customer's first and last name. See, no customer, right? I can't see the first and last name. I'm going to join it to customer. Show me the first and last name. So the first thing I'm going to do is, I actually don't have an index to query orders by the status. So I'm going to create one status, and then the field is status field. There's actually 3 of them. Great. Here we go. There's an index name called orders by status, and then I want processing. I use the match. What you're looking at here is FQL. It's a functional query language. If you come from Lisp, you'll like this. If you don't, you're going to hate it. But I'm going to say we have new syntax coming, and it's going to be based on TypeScript. So we heard our customers. We know what the issue is. We're fixing it. Anyways, when you see a set, that's a result set. I paginate. I get the tree of them. I only get the references here, so I can dereference these guys. That's map function. I can map function. So map is like your JavaScript array map. This is your anonymous function. You pass it in there. But if I do get on a ref, I'm going to get the document back, and that's what I do here. And then I can JSON search this thing. So I want data status. So you see now I got 3. I don't want everything. I'm just going to do select the status, processing. Then I can shape it. I don't want strings. I want objects. Oh, see, right? You get the point. Customer.
Nice.
So customer in here, right? It's also a pointer. What do? You dereference it, right? When you so there, I get it again, and then I actually want first
Wow.
name. So that's kind of how you write it out. Pretty verbose, but again, when the new syntax comes out, that's based on TypeScript. It's actually going to cut it
Oh,
down.
nice.
Yeah. So see, so you joins, right? Actually, this is what you want to do all along, anyways. In the current practices, we don't do that in the document database. Asset. Okay, so errors that happen here, I'm only doing a query. I can do mutations in here. I can do updates. I can create. It's asset. So this query can be 100 lines long, doing a whole bunch of things. And because of the serializability, if something happens in the middle, you don't corrupt your data, right? The action gives up and rolls back. It's like a relational database. If you're used to you doing relational databases, it's really great. Never knock on it. You get all of that.
That's awesome.
The short, right, thing I wanted to show you. I know we're out of time. I didn't show you Airbyte at all, but really there's nothing to it. The Airbyte source, this is the cloud version, is in there. I think it's alpha version. All you really need here is the API key in here. So you can get the API key from here, role-based, okay? And then that's what Airbyte needs to basically read the database in there.
That's it.
Yeah, there's more documentation here. We say, hey, don't put what this is saying is don't really use the admin key because it gives you a lot. What you want to do is create like a read only. Yeah, and then see what it does. I got fine grain control. In fact, maybe I have 100 collections in here and I only need Airbyte to read 2 of them. This is what I do. Don't give it rights. And you create some indexes because it'll need the indexes to do the appends. Airbyte will need the indexes to do. So you give it some indexes there too. Then you provide that role, get the API key, put it in here, and then that's your source.
Boom, and then move it to whatever destination you choose. Oh well, yeah, that's perfect for exit plan, especially. No, that's perfect. Wow, perfect. Okay, thank you.
It went longer than I thought.
It's partially my fault though. I get excited and I ask a lot of questions.
You asked some good questions. I love those questions.
If anyone has any questions that's watching right now, please ask away. Or else I'll probably ask one more question myself as well. What do you run Fauna on?
We are running. Greg asked, "Are we planning to add a destination?" If the answer is
good question,
is yes, if there's demand for it. So remember, right now it should be a source. Why did we do it? Because customers asked us to. It's a transactional database. That's where your source of your data is. You're putting into Cloud Lake or whatever. So it's really going that direction. If someone finds a use case, we're going the other direction. We'll do it if there's enough demand. Your question is, where do we run this, right? So we do it all in AWS, but we don't have to. So we're actually multi-cloud. So we can run that footprint, the 3 replicas. We can run that on one here, one at AWS, one Azure, one Google. We can actually like that custom footprint for enterprise customers.
Yeah.
Usually when you sign up and you upgrade yourself, you're on the multi-tenant cloud Fauna. You can get your own Fauna if you want. Right? Custom footprint wherever you want it, which cloud do you want it.
Awesome. Well, thank you for answering that. Z, I seriously want to thank you for making the time, especially preparing, which always takes a lot of time, to be in this community call. If anyone has any other questions later on, especially, or if they watch this on YouTube, how can they contact you for any more questions?
Contact me here. When you do sign up, you get a welcome email in our community. Join it, Discord. This is my contact. The best thing to do really is give it a try, because when you do give it a try, right, sending a welcome email and resources, docs in the community, who to contact, etc.
This is perfect. Seriously. Wow, Z, I really appreciate you being on here. Yeah, this is excellent. So yeah, we're going to end the community call here. And thank you everyone who joined today. I really appreciate this. And we'll see you at next month's community call.
Cool.
Bye,
Thanks a lot. Fun.